everyone, my name is Dan Westerberg. I'm a field application engineer with Lynx Software Technologies. Today we're going to talk about LYNX MOSA.ic and RunSafe Security's Alkemist code protection capabilities for protecting runtime binaries on an embedded system. This was a demo that was shown at the MOSA Summit in September of 2023. LYNX MOSA.ic is a framework of tools for creating complex systems on multi-core processors by integrating multiple runtime operating environments, such as our Lynx 178 real-time operating system, on top of our hypervisor technology known as Lynx Secure. In addition to our real-time operating system, LYNX MOSA.ic provides the ability to integrate a number of operating environments, including build root Linux as a feature-rich application development environment. One of the challenges of using a Linux environment is because you're using open source libraries and packages, you may unintentionally bring known vulnerabilities into your system through libraries and applications. RunSafe Security has developed a number of technologies to address vulnerabilities in runtime systems like that. In particular, today we're going to talk about Alkemist code that is a capability that is linked into runtime executables and randomizes the layout of functions to avoid potential memory layout issues that can be exploited. In particular, Alkemist code provides fine-grained address randomization within binary executables memory footprint, thereby preventing attackers from exploiting known address layouts of applications and taking advantage of things like buffer overflows for triggering errors that can execute malicious code and compromise the integrity of the system. We have a quick demonstration here to show how this technology works. Within LYNX MOSA.ic, we've created a single build root Linux guest virtual machine running on top of a multi-core processor. Within this build root Linux virtual machine, we have a demo application that represents a logging capability for keeping track of GPS coordinates on an avionics system. And that application has a buffer overflow vulnerability that a malicious packet of GPS information will trigger and try to compromise the integrity of the system. In the unprotected binary of the application, that malicious packet will in fact compromise the system and leave a breadcrumb around indicating that the system was in fact compromised. Running the same demo, except with the Alkemist code protections linked in, when that memory buffer overflow vulnerability is triggered, the application will crash, but no ability to compromise the system is able to be realized because the memory address layout was changed due to the randomization. So within our build root Linux environment, we have the demonstration application, and the first time we're going to run it, we'll be using the unprotected binary. Again, this is a GPS logging application. So it's receiving GPS coordinates through a data packet interface, and it'll receives a maliciously formed packet that causes the buffer overflow vulnerability to be triggered. We've captured here that, yes, in fact, the vulnerability did compromise the system, and in the temp directory, it left around a breadcrumb indicating that malicious code was in fact executed and compromised the integrity of the system. If we run the program again, this time with the Alkemist code protections linked into the executable, same set of data and malformed packet are sent to the application, triggering a failure, but this time the application crashed, but because the functions were randomly moved around in the address space, the vulnerability was not able to be triggered. And this time, within our temp directory, we see no breadcrumb indicating that malicious code was in fact executed. To make use of the Alkemist code technology within applications, the normal flow of creating an application is you take your source code files, you compile it using your standard tool chain and link it into a binary executable. Alkemist code intercepts and takes over the process at the link stage, where the Alkemist code technology is linked with your application, creating a new object file that's now a protected binary with the function randomization capabilities built in. It's at these touch points in the system compiler and linker that Alkemist code is integrated with Buildroot Linux, making it easy to create protected binaries using the LYNX MOSA.ic Buildroot framework. So the benefits that can be seen there are immunizing your runtime executables using RunSafe's Alkemist code protection mechanisms, so that you significantly reduce the attack surface of your binary. And because the randomizations occur every time the application is started, it's a moving target defense, so attackers cannot spend any time to analyze potential vectors of attacking your address space. Any questions or inquiries? Again, my name is Dan Westerberg, and I'm a field application engineer with Lynx Software. Thank you.